Hi everyone, today we will do some basic derivative practice. So there's good news, I have no new rules today. So what are we going to do instead? We will practice, practice, practice. And why are we going to spend so much time practicing? Because that's how we really learn. Think about when you want to learn something new, whether it be a video game, how to decorate a cake, play a guitar, or if you're just studying the stars. The way that you learn things is from repetition. This won't be the only time I do a video like this. There'll be plenty of times where I teach you something new, some kind of new rule, and then later we're going to come back and look at how that works for a bunch of different functions. So let's quickly review what we did previously. We really had two rules. The first one was the constant rule, which said if f of x is equal to c, then the derivative would be 0, so constants just go away. And the second thing was the power rule, which said if we have f of x is x to the n, then our derivative is n times x to the n minus 1. The power came down, and then it reduced by 1. I'm throwing on a third line here, which is a specific case of the power rule. So this says if f of x is k times x, then the derivative of f will just be k. So if I just have one x, x is just going to go away, and I'm going to keep the constant. I feel like students do better when I have this as a third rule, but it really is just a really specific case of the power rule. So when I say we have a lot of practice, I mean we have a lot of practice. I have these 18 problems that I'm going to do in the video, but I wanted to quickly throw them here at you so you can kind of see what we're going to do. So I'm going to start off kind of easy and get harder. Throughout the video, feel free to pause me at any time, try some of the problems, and then push play to see if you got it right or wrong. Our first one says f of x is 3x. I'm going to take the derivative. F prime of x is just going to be 3. So this is like that k times x that I put up there. So if I had f of x equals kx, then the derivative is just k. So that k I keep, the x went away, there's my answer. Number 2, g of x is 8x squared plus 2x minus 55. G prime of x, I'm going to bring the 2 down, 2 times 8 is 16, x is now power 1, plus derivative of 2x is just 2, negative 55 is a constant, it goes away. As we go, remember, powers are going to reduce because we're doing derivatives. Number 3 says h of x is 12x plus 16 over 4. Now, when I gave you the rules last time, we talked a little bit about you can add and subtract, but we didn't talk about division. That's on purpose. That's going to come later. So for now, if you see multiplication or division, you should think you need to simplify. So let's rewrite this. 12x plus 16 over 4 says 12x over 4 is 3x. 16 over 4 is 4. So I'm going to simplify before I take the derivative. Now the derivative, h prime of x, derivative of 3x is 3, the 4 goes away. So it's important that you simplify before you try to do the power rule. 4 says y equals 6 over x to the 5th. Let's rewrite this one as 6x to the negative 5. We want to have power, so I can use the power rule. Then y prime, I bring the negative 5 down. Negative 5 times 6 is negative 30. I have x. Negative 5 minus 1 is negative 6. Remember I said you could leave that just like it is, or if you want to, you can make that negative 30 over x to the power 6. 5 says f of x is x squared raised to the power 5. I have two powers here, so before I take the derivative, I'm going to say 2 times 5 is 10. Now I've simplified f of x to be x to the 10th power. F prime of x, the 10 comes down. I have x, 10 minus 1 is 9, so my answer is 10x to the 9. G is very similar. I want to simplify first. Now, as you're looking at the 2, make sure you're distributing that 2 to both terms. 3 squared is 9. X to the 4th squared would be x to the 8th. G prime of x, then, will be 9 times 8 is 72. X, I subtract 1, so my new power is 7. 7 says h of x is the 4th root of x cubed. Again, let's work on that exponent. It should be x to the 3/4. So the 4 that was the root becomes the irrational, and I put it in the denominator. H prime of x, I'm going to bring the 3/4 down. I have x. I'm going to write it the long way really quick for you. It's 3/4 minus 1. You can, if you want to, put 3/4 minus 1 into your calculator. It will tell you what the answer is. If you don't like fractions, you don't have to do fractions. But I do think it's a good idea to write the answer as a fraction. So I have 3/4 x to the negative 1/4. Desmos will do fractions for you. So in Desmos, I can put in 3/4 minus 1. And I see it says negative 0.25, which is a decimal. But if you look at the left side, there's a box over a box. I'm going to click on that and see how it turns into a fraction. So this is really helpful, especially if you don't like fractions. And 8 says c of x is 0.02 x squared plus 0.35x plus 953. I don't want you to worry about decimals either. They're okay. I do 2 times 2. So I keep the 0.0. 2 times 2 is 4. I have x. It's power 1. I'm not going to write it. 0.35 times x, and I have a plus 0.35. 953 is a constant. The derivative of a constant is 0, so I have my answer. So c prime of x is 0.04x plus 0.35. Look at 9 and 10. They should look very similar. One of them says x to the 5th over 6. The other one says 6 over x to the 5th. On purpose, I put them side by side so you can see how different they are. In 9, x to the 5th is a power, and 6 is a constant that I'm dividing by. I could rewrite this as 1 over 6 x to the 5th. So the 6 kind of works like a coefficient that I can just bring out. When I look at g, where it says 6 over x to the 5th, well, I could rewrite that as a negative exponent. So this time, this 6 becomes a coefficient versus 1 over 6. I have an x to the 5th versus x to the negative 5. So it's important to see that when you're dividing by a constant, you can just pull it out and make it a coefficient. If you're dividing by a variable, then you're going to have to make it a negative exponent. Let's go ahead and do those derivatives. From 1/6 x to the 5th, I bring the 5 down, which is 5 over 6. I have x. 5 drops 1 to 4. For g prime, the negative 5 comes down, which is negative 30. I have x. When I subtract 1, it's negative 6. 11 has a lot of fractions. I have h of x is 5/2 x squared plus 3/4 of x plus 1/3 of x cubed. Let's take the derivative. So at first the 2 comes down and it cancels, so I end up with 5x. The 3/4 of x, the x goes away, so I just have 3/4. And then the plus 1/3 of x cubed, 3 times a third, cancels, so I have x squared. 12, I have y equals 7x squared times quantity 4x minus 5. This 7x squared needs to be distributed to the 4x and the 5 before I can take the derivative. So I'm going to multiply by 4x and multiply by negative 5. I'm going to have y equals 4 times 7 is 28. X squared times x is x cubed. Negative 5 times 7 is negative 35, and that's x squared. Now we can do the derivative, y prime. I have 28 times 3, which is 84, x squared, minus negative 35 times 2 is negative 70x. Here's some more fractions. I have f of x is x to the 3 over 7. So I take the derivative, f prime of x is equal to 3 over 7, x to the negative 4 over 7. Again, let's quickly go over to Desmos to make sure you feel good about that. So just 3 over 7 minus 1. And I click on the double boxes, and it says negative 4 over 7. 14, I have capital F of x is x to the negative 2/5. F prime of x, I have negative 2/5. X, when I subtract 1, I get negative 7 over 5. 15 says y equals x plus 5 squared. I have parentheses around the x plus 5. This means I really have x plus 5 times x plus 5. We've talked about before, when you square a binomial, you get a trinomial. So either you remember how to do that, or you can FOIL it out, right? You could multiply all the pieces. What you end up with is x squared plus 5x plus 5x again plus 25. That really is x squared plus 10x plus 25. The derivative, y prime, will be 2x plus 10. Notice you have to do the distribution first. I have to expand this. If I just tried to take the derivative of x plus 5, I would get 1, right? And that 1 wouldn't be helpful. That 1 doesn't give me the 2x plus 10. It doesn't show me how the function's changing. So you want to make sure you do your simplification first. Same thing's happening with g of x. I again have a square, but I also have a coefficient. So I have g of x is 8x times 2x minus 3 squared. Well, let's do a couple steps. We'll start with 2x minus 3 squared. 2x squared is 4x squared. The middle term, I do 2 times negative 3 times 2. So 2 times negative 3 is negative 6. Negative 6 times 2 is negative 12, and I keep the x. 3 squared is 9. Now I want to multiply 8x times 4x squared minus 12x plus 9. 8x times 4x squared is 32x cubed. 8x times negative 12x is negative 96x squared. And then 8x times 9 is 72x. Now I can take the derivative. 32x cubed becomes 96x squared. 96x squared becomes minus 192x. And 72x becomes 72. Again, you're watching for all the powers are dropping. So 3 went to 2, 2 went to 1, and 1 went away. 17, f of x is equal to 12x to the 5th plus 6x cubed over 2x to the 4th. So another time that we're dividing, we want to first do our division of each term. So I have 12x to the 5th over 2x to the 4th. 12 over 2 is 6. Remember, when you divide the same base, you are going to subtract the exponent. So 5 minus 4 gives me x to the 1. I'm just going to write x. Plus 6x cubed over 2x to the 4th. 6 over 2 is 3. X cubed divided by x to the 4th, remember I'm going to do 3 minus 4 is negative 1. Right, this is still just the function. We haven't taken the derivative yet. Now I can say the derivative of 6x is 6. For 3x to the negative 1, the negative comes down. So I have minus 3x, and now my exponent is negative 2. We made it to our last problem. I have g of x is 18x cubed plus 9x to the 6 over 5x to the 4th. On purpose this time, it doesn't become pretty. 18 over 5 doesn't reduce, so I'm going to leave it as 18 over 5. But x cubed over x to the 4th, I say 3 minus 4 is negative 1. Again, 9 and 5 don't reduce, so I have plus 9 over 5. I have x to the 6th over x to the 4th, which is x squared. The derivative. The negative comes down. I have negative 18 over 5, x to the negative 2, plus 9/5 times 2. 9 times 2 is 18 over 5. I have x to the power 1. So it wasn't so bad. Probably didn't take as long as you probably thought when I first said we were going to do this many problems. From here, we're going to add some more rules. So there will be things about what do we do when we divide? What do we do when we multiply? So more and more rules are going to happen. In addition to the new rules, we'll have applications. We'll see how this relates to business and how people can use this in the real world.